Hi guys, we're the Duke University Greenhouse Gas Data System Update team. Our team member are Neruda, Ivy, and Tanya. Our team lead is Matthew, and our team manager is Koyu. As a start, I'm going to talk about our project background and our project goal. So Duke University Greenhouse Gas has 3 different scopes. One is direct emission and the other 2 are indirect emissions. After exploring the greenhouse gas calculation system right now, we learned that manually processing such large volume of data is very challenging. So we set our project goal as to automate the greenhouse gas calculation system of Duke University. And then on the poster, you can see there is a graph as our design workflow for our automation system. On the left, you can see different input as different type of emissions. They will be put into an ETL pipeline, formatting, and be input into a database. And they will also be input into a calculation engine and calculate a certain value like greenhouse gas. And then they will be output into different Excels for our team lead to do analyze on them.
After this, we went forward with automating how our current pipeline is. And we did this by using standardized form distribution and replaced the previously fragmented data submission tools that were present. This unified the whole process and made an easily accessible data set for the whole Office of Climate and Sustainability. The next step that was there, which was a very crucial step in the automation, was writing an office scripts for some of the Excel sheet that OCS was downloading almost every year. And with just one click, they would be able to extract all of these values from these unpleasant data that was coming from the Excel sheets, and then they were matched up with the right emission factors, which the other team members were able to scrape from the websites. And this then eliminated the need to re-enter formulas repeatedly for each data set every year.
Another aspect of the automation process was extracting the emission factors. Emission factors are values that represent the quantity of a specific greenhouse gas that has been emitted per unit of quantity of activity, fuel use, or material processed. So these emission factors are very essential in converting activity data into a standardized emission rate. So in our case, we're using metric tons of carbon dioxide per million thermal units. So we use Python scripts to automate this and to extract the values from the websites. And these scripts also included the conversion of by using GWP or the global warming potential and converting pounds to metric tons. So Duke uses 4 scripts, 4 sources for tracking the emission factors, which are the GHG protocol, the climate registry, the EPA, and SIMAP. And our script basically runs through all 4 of these sources and extracts the values and outputs like a single Excel sheet, which is in a standardized format that can be used further in the calculation engine.
For the calculation engine, we choose to use Power Automate as our tool for automation. The Power Automate flow are one for each different type of emission, and they will each take different emission factor, as Naruto talked about before, and you also extract value from the Microsoft forms. And then they will be put into right formula and output 2 different Excel for each type of emission, one per type of emission, which it pass your data for us to see how does the emission change throughout years, and also a yearly total emission data for the annual greenhouse gas report of Duke.
As we were working through this automation process, a secondary goal of our project was to create a centralized data hub which showcased Duke's sustainability efforts, and it gave insights on how the university was on track to meet its net zero emission goals. This was being in such a way that we would be showing visualizations and giving factoids and data downloads on the Office of Sustainability and Climate website. The Duke OIT had already made some visualizations for the OCS, and what we have done is try to augment those visualizations and add more insights to them, and so we have attached some screenshots of what those visualizations look like, and ideally these would be hosted on the OCS website and be available to everyone who's an enthusiast to work with and play around with.
Yeah, taking on from the website that the team was building upon, the next step was for us to communicate this data to all the interested folks, and this was done with regards to the scale framework. Focuses on transforming the classroom learning into real impact by building practical skills and applying system thinkings and support Duke's climate goals. Our project was not one of the most technical in terms of applying machine learning or data techniques, but we did work on simplifying a real world problem here. A more tangible solution was made, and we made the data process collection easier for a non-technical stakeholder. Together as a Data Plus team, we were able to leverage the use of everyday technologies and reduce the manual effort for the OCS and streamlined a system that was very time consuming before. Even though we were not able to see through a few of our initial ideas, we have successfully managed to extract all the emission factors, set up workflows, and build a robust system that will work for years to come.